All right. Oh, that's hot. Wow. Can we turn that down just a little bit? Down a little bit? I get a little animated and I don't want to like pin people against the back wall. All right. If everyone could come on in and have a seat, I want to get started here pretty shortly. All right. Oh, hey, we have video too. Excellent. Okay, so I guess I should have asked this before. We have like, what, 50 minutes and then cut over? Good enough. Okay, we'll go with that. Well, let's get started then. Thank you for coming to this morning's session on building reactive pipelines, or as I like to call it, how to go from scalable apps to ridiculously scalable systems. Who here has had their boss come to them and ask them to do less with more? You know, you've probably had this conversation like, you know, everything's going great. Your boss comes in and says, hey, that was an amazing job you did last month. What I'd like to do, though, is double your budget. And if you could just kind of slow things down, because we processed way too many orders. We made way too much money. Can you just slow it down a little bit? No, that'll never happen, will it? It's always the other way around. It's always, can you do more with less? Or more appropriately, you will do more with less, right? So that's probably why we're here today. Kind of the things that I would like to, I keep looking back here thinking I'm going to see the thing, but it's over here. The things that I'd like to cover today in our short time together are message brokers and streaming platforms, kind of give a little bit of an overview and a perspective on that, kind of some of the options, discuss those, and then talk about Spring Cloud Stream. What is it? Why use it? What does it bring to the table, if anything? Reactive Streams and Project Reactor, how do we integrate that, assuming that we go ahead and step through the first two things and go with a yes on both those. And then Spring Cloud Stream and Reactor, how to actually achieve greater scalability by bringing those together, and then turning it up to 11. Anyone catch that reference? This is Spinal Tap. I'm a retro TV and movie buff, okay? I don't get to watch nearly enough TV and movies, but I do try to squeeze them in when I can, and I always enjoy them a lot. So I am the master of terrible, esoteric, useless trivia when it comes to movie quotes and old TV quotes and what have you. And bad jokes, by the way. If you came here expecting good jokes, you're in the wrong room. I am just terrible, truly terrible, but I enjoy myself, so, you know, thanks for coming. So who am I, and what makes me semi-pseudo, almost sort of qualified to talk about this kind of stuff? My name is Mark Heckler. I've co-authored a couple of books, and I've contributed content and code to several others, a few of which even actually recognize my contributions. That was nice. It's all right. I wasn't planning to live off the royalties anyway. But anyway, I am an architect and developer, and as you might surmise from the next point, where most of my expertise has been won, it's been in the Java ecosystem, and mostly with Java. It's not a monogamous relationship, though. I do like to dabble with Kotlin. Anyone play with Kotlin here? Okay, if you haven't, put it on your list. All right, we're not talking about Kotlin today, and I know that, but Kotlin is a really fun language. It's super productive, and did I mention it's fun? It makes programming fun again. And I'm going to dispense with the usual bad pun that goes with that. Maybe tomorrow. Maybe I'll throw that out tomorrow. But it interoperates really well with Java. Sometimes I do my talks all in Kotlin. Not today, again, but it's a fun language. So if you haven't played with that, play. It's good. I am a professional problem solver with Pivotal and on the Spring team. So you might wonder if that's my official title. Nope, it's not. I just really like the sound of it. And it actually summarizes a lot of what I do pretty well. I am a Spring developer and advocate, and yeah, so that's why I'm here, to talk about this stuff. Everything, by the way, that I talk about today is open source. So there's nothing here that you can't play with, and furthermore, there's nothing here you can't actually get the source code and play with. And I would encourage you, if you see something that you think, wow, it'd be really cool if it did this and it doesn't, get involved, right? We love the community. So anyway. Okay, so let's start off with this. In the interest of time, I'm going to make a few rather necessary assumptions. I'm going to have to take a drink. I'm already fuzzing over here. But if you don't understand anything that I lay out as an assumption, just please come and see me later. And I would ask that you hold your questions until the end. If we have time, and I think we will, but if we have time for Q&A, I'll happily answer them. If not, I'm here tomorrow, today and tomorrow, and I'm always on Twitter. If you don't follow me on Twitter, first, why, right? Secondly, please do, because most of your favorite open source committers kind of live on Twitter, or at least spend some amount of time there. I do pretty much live on Twitter. I made the joke a long time ago that I spend more time on Twitter than I do at my house. And then I looked it up, and some months out of the year, I actually spend more time on Twitter than I do at my house. It's a little sad, but such is life. But that really is the level best way to reach me. So if you have any questions, comments, or feedback, please catch up with me today, tomorrow. But if you don't think of them until later, by all means, please reach out to me. I can be reached via email, and I'll give you all my coordinates. Well, actually, I think, yeah, they're thehecklers.com is up there, marked at thehecklers.com, but I'll shoot them up at the end. But mkheck on Twitter. And my DMs are open, so if you have a question you want to throw out publicly, that's great. If not, just DM me. It's cool. But anyway, getting back to this. For starters, some of the assumptions I'm going to go through is, for starters, I'm going to assume that you understand the benefits of moving, at least to some extent, from a monolithic architecture to a microservices architecture. Even if you maintain some monoliths within your organization, and there are many reasons you would do this, a few of which might even be good ones, right? But even those monoliths will need to communicate with external services and systems. So either way, what often happens is that a REST API is usually pressed into service to do so. And REST APIs have numerous benefits as well. And I suspect you can name several of those too. Many of us probably know about Jeff Bezos' famous memo from several years ago. Sometimes you hear people talk about the 2 pizza box team and all that. But the memo basically had several kind of directives outlined in it. And in my talk tomorrow, I thought I had it in here, but I don't. But in my talk tomorrow, I actually throw up a copy of the key points. He didn't specify that everything had to be via REST, but he did specify that everything had to be exposed as a service interface. Every bit of functionality at Amazon had to evolve rather quickly to be exposed via service interfaces. And his reasoning was that if you have to reach out to several different groups and talk to several different people and try to go behind and access, the data store here and this API there and this real mishmash of things you have to do to make your stuff work, that's a terribly brittle system, right? He didn't necessarily want to discourage people from talking, but if the only way I can make my stuff work with your stuff is if we have constant ongoing dialogue, maybe you forget to tell me something. Maybe I make you mad one day and you just don't tell me, that never happens, right? But the point is that everything had to be exposed via well-published APIs, and that increased the robustness of the distributed system. It also, coincidentally, made it much more consumable externally to Amazon, which of course meant that eventually they went from being a small bookseller to a massive globally dominant cloud platform. Worked out pretty well. By the way, he signed off on that with anyone who doesn't do this will be fired. So there was some kind of motivation there to do it. But it worked out, again, pretty well. You may also be well aware of the 12-factor manifesto. Again, if you aren't aware of that, please see me afterward. But basically, it was a manifesto put forth by the Heroku engineers, Heroku being a platform as a service, to make, again, services more consumable by other services. Neither of these specified, per se, REST APIs, but what they did do basically, REST APIs became a very strong beneficiary of that because they became the obvious path forward in most circumstances. So anyway, REST APIs have enjoyed extensive use for, again, many, many different reasons. And for the most part, they work and work well, right? But there are some problems with using them for all inter-service communication. For starters, both services, when they communicate between 2 services, must be online at the same time. They also typically have to be able to scale together because they have to scale fairly linearly in terms of number of instances when the load increases. So for traffic surges and spikes and things like that. One of my favorites, the network must be performant and stable because that always happens, right? The network is always there and it's always super fast. Well, probably not. But these are some particular shortcomings that an HTTP-based API in which it can let you down. Because failures do inevitably occur. What happens when the network falls out? What happens when an instance of one or the other service crashes, right? So performance and reliability and resilience become a real issue. Messaging platforms can reduce or eliminate these concerns in various ways while improving your architecture in various other ways. Typically, they're part of your critical infrastructure, which means that your cloud provider or your critical infrastructure team maintain them, keep them alive and up and running at all times. It's a very important thing to do so. Messaging platforms typically provide fully configurable delivery guarantees and retention and things like that, meaning that any message received is verifiably delivered, even if no consuming service is online at the time that that message enters the queue. Message producers and consumers are separated temporally, as I mentioned, but also locationally. When a message comes in to a consuming service, it doesn't have to know where it came from. Doesn't care. Doesn't have to know when it came in. Again, doesn't care. It just knows that it has a message it needs to process. And scalability dramatically improves because producers and consumers don't necessarily need to scale together. Kind of makes sense. Again, there's no direct connection. In short, anytime you need better performance, reliability, scalability, resilience, in inter-service communication, a messaging platform should probably top your list. And there are multiple options in messaging. The big ones, though, are RabbitMQ, Kafka, Amazon Kinesis, Microsoft Event Hubs, and Google Cloud Pub Sub. And kind of the first among peers, and there are others, by the way, but those are the big ones. And the first among peers of those are RabbitMQ and Kafka. The reason I say that is because RabbitMQ, its primary protocol that it implements is AMQP, Advanced Message Queuing Protocol. It does implement others, but that's kind of the daddy rabbit in the business world. Yeah, they don't get any better than that. That's my best joke of the whole day, so... So it's a dominant protocol, right? And Apache Kafka is a very dominant system in terms of the other providers, the other, I hate to say proprietary, but certainly bespoke messaging platforms typically will support AMQP. They typically will support a Kafka API. So they are, in my mind, and many others, they're kind of the first among peers. So let's see, what else? Probably covers that well enough, I think. So what is Spring Cloud Stream and why use it? Well, as you might imagine, one size doesn't fit all. Perhaps you've chosen RabbitMQ as your standard messaging platform. Or maybe you've chosen Apache Kafka. That's fine. Maybe some of your requirements are handled by each. Or maybe your company has standardized on Rabbit, and your company then acquires a company who's standardized on Kafka. So who always gets stuck trying to integrate all these systems, right? We do. It's so much fun. So it would be really cool if there were a uniform way to interact with both services and more, right? So you could focus on the business at hand, the things that you want to accomplish and need to accomplish for your organization to drive it forward, versus maybe learning more about Kafka replication. Well, it turns out there is, and that's Spring Cloud Stream. Spring Cloud Stream provides a powerful, opinionated, yet extensible abstraction for messaging platforms. So you can write your code to be independent of who lays the pipes underneath. Binders make all of this possible. Binders are specific libraries, or libraries that are specific to a particular platform that interact with the drivers for that platform, so that you can basically select your binder, select your driver, create your settings, write your code, and bam, you're up and running, which is pretty nice because that allows you to solve your real-world problems and do things, one, that makes your organization more successful, two, that may get you a bonus, right? That's always a nice thing. Spring Cloud Stream is based on Spring Boot and Spring Integration. Spring Integration has very versatile hooks for different tools, different pieces and components. Spring Cloud Stream focuses in on the messaging platform's part of that. And Spring Boot brings its auto-configuration and ease of deployment and dependency management to the table too. So it makes things very easy and streamlined for you to be very productive with, which is also nice. Spring Cloud Stream handles a lot of the heavy lifting for you while still providing access to every control underneath the hood if you need to. On top of that, no pun intended, or maybe a little pun intended, if your environment does change, let's say your CTO reads an online tech magazine and decides that everything needs to move to Kafka. That never happens, right? But let's say that does happen. You can switch messaging platforms by simply changing binders and doing a rebuild. Or if you've maybe seen this coming, you may be able to even do that dynamically if you planned ahead, which is pretty nice too. Hopefully, none of us will ever have to have that much of a contingency plan in place, but it does happen, right? Sadly. Okay, so did that advance? I guess it did. Yeah, so reactive streams and Project Reactor. This is where we divert just a little bit, because all this stuff has so far been talking largely about Spring Cloud Stream and about the messaging platforms. But what does Project Reactor and reactive streams bring into to the mix? I love this quote because everything that I'm going to be talking about just for the next 2 minutes is reactive programming. Anybody heard of reactive programming? Doing it? Yeah, for the rest of you, and maybe just a quick refresher, the Reactive Streams Initiative was created by several organizations, several people from different organizations, who saw that largely the problem in terms of scalability was in the interactions, right? It's not within the app as much as it is the communication between the apps and what? Other apps, right? Between various different microservices, or between a service and its data store, or a service in the file system, or what have you. So it's in those interactions, the streams, if you will. And several companies got together, several different folks, very sharp folks from different organizations. So organizations like Pivotal, also Twitter, Kazing, Red Hat, Lightbend, and they figured that they needed to come up with some kind of a reactive streams specification. I'll get into the details of that here in a bit, but it's all predicated upon reactive programming. And I love this quote by one of our Project Reactor team members, Rossen Stoyanchev, who said, in a nutshell, reactive programming is about non-blocking, event-driven applications that scale with a small number of threads, with back pressure as a key ingredient that aims to ensure producers do not overwhelm consumers. Now, that packs a lot into one simple statement, which is why I like it, but let's unpack it a bit. You typically, in the Java realm, the way we've scaled is to scale out with threads, right? So for each additional connection, we spin up another thread, which works really well for a very small number of threads. But what happens is it doesn't scale extremely well, because when you get to that n+1 number of connections in terms of the threads that you have, that performance hits that hockey stick and goes up, right? With reactive programming, you have an event loop that manages a small number of threads. So it's much, much, much more efficient. Now, at the very low number of threads, it's less efficient, right? It's hard to get more efficient than I issue a request, I'm waiting, and as soon as you get the response, you send it to me and I have it. You can't beat that. Blocking is amazing when it's one connection, or even a very small number of connections. But when you want to scale dramatically, what you typically want to do is insert that event loop and manage that better, because then you don't just have all these threads sitting there idle doing nothing, waiting for a response. I'm hitting this kind of fast so I can go ahead and move through this, but again, if you have questions afterward, please see me. Back pressure is another key ingredient. Sometimes folks see reactive programming and they think, hey, this looks a lot like asynchronous programming. What's the difference? Asynchronous programming has a couple problems. One is it's not very readable, right? There's an expression called callback hell. Anybody familiar with that? That was coined by an optimist. It's worse than that, right? Because you typically, when you have your callbacks, you say, hey, when this finishes, do this, call this method. When that finishes, call this one, and you create this very massive pile of spaghetti. It gets really difficult really quickly. The other problem it has is there's no way for a slower consumer to push back. So what typically can happen is if you have a slow consumer and a super fast publisher, is that consumer is overwhelmed and just falls over. With reactive programming, you have back pressure. So a slow consumer can say, I can only handle 5 values or 10 or 100 or whatever it is. Just give me those values. And when I'm ready, I'll let you know. When I can process more, I will request more. And it gives your slower consumers, maybe that iPhone, 3 countries over, a way to better manage with back pressure that flow. Now, it doesn't change the fact you have a very fast producer, but what it does do is it shifts the control for that back where we have control on our services here, right, versus that iPhone somewhere else. Okay, so I've hit that kind of quickly, but I do, again, want to keep rolling forward. Simply using messaging and streaming platforms can help your scaling immensely as they provide a robust and reliable infrastructure, often with delivery guarantees, what have you, that reduce dependency on options that are more tightly coupled and more prone to communication hiccups and timeouts. But even with messaging platforms, there are potential choke points and pain points, especially when using them with systems composed of non-reactive applications. And again, while you can just scale out, you're still limited at a much lower level by how much processing each instance of your scaled out sync service can handle. Reactive streams-based microservices extract more work with fewer resources and reduce or remove those remaining barriers to scalability. Because with an event loop managing that small number of threads, those few threads can be kept alive and hot at all times. So it kind of pushes the red line out and maximizes the processing throughput to your clients and subscribers. Today, this is kind of a work in progress, some of the stuff I'm going to be showing you. Tomorrow I talk more about the kind of the tried and true, and here's where we are, but today we're looking forward. We're standing on that edge and reaching forward a little bit. So it's kind of an exciting time, and I'll explain as we go. I mentioned earlier the Reactive Streams API. The Reactive Streams initiative defined 4 different interfaces, right? A publisher, which is the thing that produces objects of type T, let's say. You have a subscriber, which consumes those objects of type T. Subscription is just the contract entered into between subscriber and publisher. And then the processor actually incorporates both subscriber and publisher interface capabilities, because what that does is it will, processor will actually get values, manipulate them in some way, and then pass them downstream to its subscribers. So again, it's a pretty simple concept. There are various different implementations of the Reactive Streams API. Arguably the best is Project Reactor. I say that completely biased, but it actually is being picked up and used in a lot of other different libraries and frameworks, so it's quite robust. So I added this after the last time because I gave this talk once before, and I was a little, I think it helps to understand what I'm going to be coding before I code it, because that way it gives a little bit of context. I'm going to keep this in a fairly simple example because I want to show the capabilities, not necessarily a complex example, but I want to show how it all fits together better. And in the Spring Cloud Stream world, you have 3 different interfaces that are predefined. You can define more. You can create crazy different combinations if you want to. All you have to do is create more message channels and observable channels and link them together in any way you want. But there are 3 that are already predefined for you. And this looks probably pretty familiar, which I'll get into in a moment as well. But you have a source which produces values and pushes those values into a pipeline. And I'll try to keep at that pipeline level of terminology, because otherwise I devolve into either Rabbit or Kafka speak, and then I sometimes mix them just for bad measure. So I'll say pipeline and try to keep it at that level. But you'll have a source which will produce values, a sink which consumes those values, and that's kind of the endpoint, and then you may have 1 or more processors in between there that will manipulate them and pass them on. So, again, reactive streams in context. There we go. It looks a lot the same, right? There's a great correspondence between your reactive streams interfaces and the interfaces defined in Spring Cloud Stream. This isn't really by accident, right? So your publisher will produce objects of type T. Your source will produce what? It'll produce messages based on objects of type T, right? Your subscriber roughly corresponds to a sink. That's the thing that receives the values. The actual pipeline themselves, the RabbitMQ exchanges and queues or Kafka topics roughly correspond with that subscription, the pipeline does. And then a processor, of course, kind of makes sense. It's like a processor. I should say just a little bit of background information, because again, everybody has a little different implementation of reactive streams who does provide one. From our perspective, from the Project Reactor perspective, it kind of made sense to specialize that publisher interface into 2 different things, because in standard Java, when you, let's say, have a method, you can return an object of type T, or maybe an iterable of some kind of type T, some kind of collection. So 1 or many, right? Well, the same thing kind of goes in the reactive world. You may want to respond with 1 particular object. So instead of having a publisher, which is pretty nebulous, we define a mono as having 0 or 1 values. And then if you have a small collection or a large collection, we consider that to be a flux. So flux is 0 to n. Maybe it's a small collection, maybe it's an infinite number of items over an indeterminate amount of time. And then you have a mono, which can return 0 or 1. Some methods actually apply equally well to both, some don't. Thus, again, it made sense to kind of specialize. So with that, let's code. That's my seat. Live coding. It's always a hot seat, so that's fine. Hopefully this will work well, and if not, we have a lot of eyeballs in here to help me figure out what I did wrong. I have been known to typo. It's an unfortunate thing, but I'm counting on the front row to catch my typos before I hit build. So if you don't catch them, it's on you, right? Front row is going, dang, shouldn't have sat up here. All right, so let me switch this back to non-mirrored, or to mirrored, I should say. Sweet. All right, so let's blow that up. And there we go. Okay, so can everyone see this? Last time I started presenting and I forgot to mirror, and everyone's going, stop, stop. Okay, so this is the Spring Initializer. Those of you who are familiar with the Spring Initializer are probably saying, no, it's not. This is fairly new. It's only a couple weeks old. And there, as with all changes, there are good things, there are bad things, mostly good. But if you see something there that's missing that you liked, or that's a useful capability, or you just wonder, raise an issue with us, ask the question. We are taking feedback to, again, get the best of all worlds. But this is your starting point for Spring Boot-based microservices on the web. You don't have to go here. You can just write it all from scratch if you want to. Not the most productive use of your time, but you can. You can also access the endpoints via your IDE or curl or HTTP, what have you. But this is a really good place to start. I like to go here. It makes me happy. And you can choose certain different defaults and launch into your project building that way. It doesn't generate code for you per se, other than the main application class, main method. But what it does do is it allows you to very easily select your dependencies and choose from a few different kind of options that are presented to you in an opinionated way. So it kind of makes some choices for you. If you don't like those choices, you can blow it out to here and choose from more options, right? But I'm just going to go with fewer options and go quickly through this. But even with the streamlined, simple version, you have choices. So if you're a Maven developer, you can create a Maven project, right? If you're a hipster, you can create a Gradle project. I already took off my hoodie, so I'm not feeling the hipster this morning, maybe tomorrow. So we'll go with Maven. I'm going to stay with Java today, but again, if you're a Kotlin person, that's great. Groovy, that's cool. I'm going to stay with the current version of Spring Boot, because that gets us our latest, greatest of Spring Cloud Stream as well. I'm going to change this to the Hecklers, because it doesn't work otherwise. I'm kidding. It does work. I just like it, because it's my domain. So I'm going to create a source. And let's choose some different dependencies to add. I'm going to bring in the reactive web dependency, which gets me Spring Web Flux, which is, again, built around Project Reactor. And I should say you don't have to use Spring to use Project Reactor. It's used in a lot of different settings, right? Even some Android users are using it, and that's cool. I don't know why you wouldn't want to use Spring, but you don't have to. But Web Flux is built around that. And then Netty is the default engine, right? You don't have to stay with Netty. Just like with Spring MVC, you can switch off to other options like Tomcat or Jetty or Undertow. It just has to be a Servlet 3.1 compatible engine, right? So you can get that asynchronous capability baked in. Oh man, I freaked people out from the front row. That's never a good sign. I was kidding, all right? Oh, yeah. I guess I should. Yeah. Oh, they just moved it earlier, so I'm not sure. Can we move the speaker? Because it is blocking. Yeah, just a little bit back. I'll trust I'll trust the hardware folks to do that. Can you move the speaker back so we don't obstruct the view? Maybe, please. All right, I'll keep going. Hopefully that'll happen. All right, so I've chosen Reactive Web. I also want to bring in Reactive Cloud Stream. So there we go. Oh. All right. And we're back. Okay, so I won't ask about the speaker again. I'm sorry, you may have to move. Anybody a fan of the Big Bang Theory? Yeah. So you probably remember the part where Sheldon's complaining about the food and Penny says, never complain about the food to the people who can spit in your food. All right, so he wasn't complaining, I wasn't either. We just asked about the speaker, so all right. Okay, so where was I? Reactive Web, Reactive Cloud Stream. I'm also going to bring in Rabbit because we need, again, something to bind to. And I'm going to use Rabbit for my examples today. Tomorrow I'll do some Rabbit and Kafka, but today we're going to stick with Rabbit primarily. And then Lombok because I'm a lazy developer. Lazy good, not lazy bad. I saw somebody applaud. I actually have a love-hate relationship with Lombok. I love what it can do for you. I just don't like what it does to you. But I find it's very useful for demos. You might wonder if you're a Lombok person, a Lombok fan, why I don't use @value. @value changed in 1.8.4, and it completely broke all my stuff. @data and @allRsConstructor is much safer. Again, you wonder why I hate Lombok. But again, it works pretty well for demos. So, oh, no internet. Oh. Okay, probably fine. Let's go back to this and try again. Oh, that's better. Oh, hey, well, let's find out if it picked up where it left off or not. What could possibly go wrong? An inauspicious start. Okay, so let's go to the desktop, and let's unzip this, and we'll open this in our favorite IDE, NetBeans. Just kidding. Any NetBeans fans? I pick on my friends, okay? I like NetBeans. NetBeans is an awesome IDE. Actually has really great Spring Framework and Spring Boot support. I used to use it all the time. I find that IntelliJ actually fits my workflow better. It also, with the folks behind IntelliJ being JetBrains and the folks behind Kotlin being JetBrains, I find that it actually has arguably the best support for Kotlin. So I've switched to that, but it doesn't matter. Any Eclipse users? Yeah, a couple. That's fine. It's all right. You don't have to be embarrassed. At least it's not Emacs, right? I mean, come on. Actually, Eclipse, we have a build of that at Spring Tool Suite, which has great cloud deployment capabilities. Every time somebody shows it again, I go, oh, that's new. Oh, that's cool. But I'm kind of in my IntelliJ world, so it's cool. Oh, let me switch this out. I can't believe I left that. Let's see. So change the appearance. I actually find that high contrast pops a lot better in kind of semi-lighted rooms here. And then I'm going to go to presentation mode, which amps it up a little bit more even. Okay, so let's go to our application.properties. This is where you put your kind of sensible defaults, and you can pass in defaults from the command line or have an external application.properties or .yaml file. But this is kind of where I put things, and it's just the general default, which is kind of nice to get up and running quickly. I'm going to set the server.port equals 0 so I can scale, should I want to. And then for our for Spring Cloud Stream, you have certain things that are predefined, like your bindings. As a source, for sources, you have output channels. Again, I kind of mentioned you have your source processor and sync. In various different combinations, you have input and output channels. For a source, because you're the thing that produces values, it's just an output channel by default. Again, you can define your own should you want to. But I'm going to just use the defaults with output. And then I can define the content type. For instance, if I want to produce application JSON, that's cool, but that's the default, so I don't have to put that. I just like to show it. And then Spring Cloud Stream bindings output dot destination. This is my exchange. It roughly equates to your exchange in Rabbit. So I'm going to just push this out to our processor pipeline. And then I think that's all that I really need for my source. Let's see if I go to, If I go to my POM, everything looks good there. Yeah, so we're good. So let's go to our main application, and let's start coding, right? So the first thing I'm going to do is create my domain. I'm going to just create a subscription-based service, sort of like Spotify, right? But Spotify already has that name. They get really nasty when you try to use it. So we'll just create a subscription-based service and track subscriptions to our wonderful new service. So what kind of attributes will we need? So we need member variables for ID. We want to track, actually I want this to be a subscriber, don't I? Yeah, so we can track our subscribers. Kind of makes sense. And we want to track first name and last name, and then maybe we want a timestamp for when that subscriber actually subscribes, so a subscribe date. I'm going to use Lombok again, so @data gets me my getters, setters, equals, hashcode, and toString methods created for me. Very nice. And then I'm going to ask Lombok to provide an all-args constructor for me, which means for every member variable, create create a corresponding parameter in a constructor. So that's pretty nice. It keeps things very nice and concise. I'm also going to create a subscriber generator. So class subscriber generator, because that way I can generate a whole bunch of subscribers and push through the pipeline for our demonstration. Right? That's kind of nice. So let's see. I'm going to just create some arrays of string arrays here. So first, names equals. Now, I don't know if I mentioned or not, but I do travel quite a lot. I'm from the central US, which means I'm never there, which is cool. This is my second time actually at Vox Days Bucharest. Any first-timers here? First-timers, yeah. So hopefully they'll let us all come back, right? This is an awesome event. I don't know if you realize how cool it is, but I got to come last year for the first time and just loved it. So great group, great venue, great event. So again, hopefully they'll let us come back. But I do fly a lot. I spend a lot of my life on airplanes. So I hear the phonetic alphabet quite a lot. So I kind of tend to weave that into my demos. I have no life, it's true. But we'll go with the phonetic alphabet here for Alpha. That'll be a good first name, right? Bravo, Charlie. That actually works. Any Charlies? None. Okay, well, any Deltas? Guess not. Any Echoes? Echoes. Okay. Foxtrot, Golf, and Hotel. Sweet. And I'm just going to split those up. I think trying to type too fast, front row, you're going to earn your keep today. And then the next thing I'm going to do is just do the same thing for the last names. And then I also want to create a random so I can just generate some random numbers, if you will. So new random, boom, and then some integers. No, I don't want those final because I'm going to need to tweak those. So equals 0, j equals 0, and then that should be good enough. So I need to create a method. I also, let's see, actually I just need to return a subscriber, right? So we'll call this generate, our generate method. So let's see, we need to set I equals ran.nextInt, and how many do we have? 8 values. That's cool. And then we'll do the same thing here for our j, and then return new subscriber, and we'll just use uuid.random.toString for our ID. We'll take our first names, and we'll get the ith element. Ith. Okay, like I said, my sense of humor is terrible, but I have a good time. And then we'll set the timestamp to now. So that's good enough. That's an adequate generator. I do need to make this a component, right? So we can load that as a bean into our bean bucket. And then we want to, let's see, I need to create something to send those values out. So I'm going to enable binding here to our source interface. And then let's see, we'll call this class spammer. We're going to spam the message queue. That's cool. All right, so I'm going to inject my source here, source, and then private final subscriber generator, so we can generate it. Now, I can just create a primary constructor, right, in which, oh, I'm slipping into Kotlin, create a constructor here in which I inject these as parameters. But here's another nice thing about Lombok. This is the love part. I can just have Lombok create an all-args constructor, and it will create that constructor for me. Spring Boot will auto-inject those for me, so we're off and running. So now I need to create a post-construct method. Class, ha ha ha. This will return a flux of subscribers. And again, that flux is that publisher of 0 to n values. So that, there we go. And we'll call this spam. I also do need to make this a stream emitter, right? So it'll emit things into my stream, and I need to define where my output is going at output, and that will be my source.output. There we go. Okay, so let's generate some subscribers. I'm going to just do a return flux.interval. This will create a flux which will produce values at some predefined interval. So I'm going to assign it a duration of 1 per second. And then I could just map this pulse to a value. But what I really should do in a better practice is define what happens if we have a slow consumer on the other end. Now granted, at 1 per second, we're probably not going to be overwhelming any of our consumers, right? But it's a good practice to define what happens if you are producing too many values for a slow subscriber. So what I'm going to do is define what happens on back pressure. Now you can define buffers and define sizes of buffers and things like this. But in our case, we are only concerned about the now. If we don't happen to request 10 in between the 1 or 2 or 10 or 100 that we request, we don't care. We'll just pick up where we left off. So I'm just going to drop any intermittent values. And again, in this case, we're never going to lose any, but so we do. Okay. But that's up to you. That allows you to define what happens here in the service, which is kind of nice. And then I'm going to take that pulse, that interval, each pulse that comes out at that every second, and I'm going to map that to a new subscriber. And I'm going to use my generator to do that. I'm just going to generate a new value. Piece of cake, right? So we've created our source. Let's go ahead and create a processor and a sink now so we can see how it all ties together. So I'm going to go back here. Oh, it wiped out all my stuff. No. The hecklers. I worked so hard for that. Processor. And let's see. Reactive web. Reactive cloud stream. Making me work for this here. Okay. Rabbit and Lombok. Can't forget Lombok. Okay, do I have everything? I do. Okay. So let's save that down. There we go. And let's open that up. IntelliJ has this weird thing where when you're in presentation mode in one window and you're not in the other, it kind of slams back and forth a bit. Still working with them to try to isolate that, but for the time being, we'll just do that. Okay, so application properties, once again, I set my server port equals 0. This is a processor, right? So it has input channels and output channels defined by default. So I'm going to say Spring Cloud Stream Bindings input, and I'm going to define my destination. And again, we were pushing things to a pipeline called processor. I also, as an input, can define a group. And roughly in Rabbit, that equates to in anything, it's a consumer group, so you can scale. If you're getting too many values coming at you, you can spin up another instance, and they can do the competing consumer pattern, right? So it allows you effectively to double your processing capability in your processor. So I'm going to define my group to be the same. I also want to be able to push this to a subsequent pipeline. So I'm going to bind to my output channel of a destination of sync. Now here's something that's kind of that on the edge looking forward part, and this is where it starts to get really exciting, or at least a hint of what's really exciting. I'm going to provide a function definition. We'll come back to that, put a pin in it, but this is where I really get excited for the kind of the looking forward part. So let's see, our code, let's see, there we go. So once again, we need to define our domain at data, at all-args constructor, class subscriber, private final, string ID, first name, last name, private final, instant, right? Subscribe date. Perfect. Okay. Now, if you've used Spring Cloud Stream before, you may think you know what's going to happen. I'm going to define a message endpoint, right? No, I'm not. This is where, again, it's kind of on that edge looking forward. What I'm going to do, though, is create a class that enables, I'm going to bind, actually, to my processor, processor.class, and let's see, class. Let's call this, well, we'll just call it message processor. Why not? Processor. And I'm going to define a bean here. This bean will actually implement a function, a standard Java function, right? So it's going to function, it's going to take a subscriber, right? And return a subscriber, pass on a subscriber, and we'll call this process. Perfect. Okay. So if I look at function, the definition of function, it's a functional interface. It also has a single abstract method called apply. Again, it takes an object of type T, it passes on an object. Oh my goodness, we're running short on time. Charge forward. Okay. So panic sets in. Okay, can we do this? So it's going to take a subscriber and pass on a subscriber, but with a functional interface and a single abstract method, what can you do? You can supply a lambda that provides that implementation, and that's exactly what we're going to do. So we're going to return, and we're getting a subscriber, right? Here's our parameter, and we're going to create a new subscriber. I'm going to cut a few corners on this so we can move through and get done roughly on time. And again, all the code is out in a repo, and I'll share that. So I'm going to take my sub here, and I'm going to get ID. And we'll do something very simple here. We'll get the first name, and we'll to uppercase that. We'll grab the last name, and we'll uppercase that. Again, real-world examples for the win. But we're pressed, so it'll have to do. So this allows us, actually I'm going to just call this uppercase it. So we can grab that, go back to our application properties, and this is our function definition. So we've provided a bean, oops, and that's our message processing bean, okay? So let's go and create our sync really quickly here. Sync, and generate that. Boom. Open. And we'll open that. And there is IntelliJ again. Yay. All right, full screen, one. Here, we'll go to our application properties. Once again, server port equals 0, Spring Cloud Stream bindings. A sync has inputs. It has a defined input channel. So we'll take that and we'll say our destination is sync. And here our group will also be sync. So again, we could have competing consumers. I'm also here going to define a function definition, which we'll come back to. And again, we will define our domain at data, at all constructor, class, subscriber, private, final string, ID, first name, last name, private, final, instant, subscribe date. Okay, perfect. Now here, what? Oh, I do. Thank you. Who caught that? You get a virtual t-shirt. I would give you my t-shirt, but then people would flee. That would be bad. So, okay, so I'm going to enable binding to, again, our sync, in this case, our sync.class, and we'll call this message sync, right? So let's see, we want to, once again, create a bean. This will implement a consumer, and we're going to consume a flux of subscribers in this case. Yes, that's fine. And consume. Perfect. Consume. Now with this, again, we can provide that lambda. So I'm just going to return, and this is taking a flux for the parameter. So flux.subscribe. We'll just keep it simple. So system.out, print line, and actually I'm just going to grab that, and we'll go to our application properties and paste that in there. Okay, let's go ahead and run this. We're going to run our sync, fire that up so it can catch values as it comes online. Normally, I like to show this connecting to a cloud-based one too, but time is short, and frankly, with the Wi-Fi dropping out, it's probably a bad idea anyway. So there's our sync. Here's our processor. Let's fire that one up. Got to get to the coolest part. This is kind of the neat part showing. And then we go to our source, and let's start that pushing some values. Okay, let's go back to our processor. We see them coming in. We also see they're uppercased. Wonderful. Same thing with our sync. I'm going to go back and kill my source because now I can show you what arguably is a very good sign of things to come, right? So we've created a bean here with which we can uppercase things. It's one function that we're saying, here's what you should do as a processor. What happens if you want to create another something to operate on that, right? So let's create another bean. We'll create a function that takes a flux of subscribers now. Okay, subscriber. Yes, that's fine. And it passes on, it returns a flux of subscribers, right? And we'll call this reverse it. Yes, you'll probably have your boss asking you to do this all day, or first of next week. So I'm going to just return, and this is a flux. So we'll take our flux, and we'll do a flux dot map. So we'll map each value that we're getting from our flux to something else. We'll just say a new subscriber, and we'll use our, let's see. Actually, I need to take my old subscriber, right? And old subscriber dot get ID, and old subscriber dot get first name, but actually I want to reverse name that, right? Reverse name that. Perfect. And then we'll reverse name the os.get last name. What have I got here? There we go. Last name. And then we'll just grab our os.get subscribe date. Perfect. And there we go. Now we need to create this, right? So we'll create this method, and we'll return a string. Whoa, what happened there? Oh. There we go. And then down. Oh. Oh, man. Okay, hold on. Let's see. So I've got this. Here we go. There. And then that looks good. Oh, yes. Thank you. Oh, whew. See, this is man, front row. Where were you? I mean, we have people from the back saving us here. Okay, so we've got this. We're going to reverse the name. This will just take a string. We'll call it S. Return new string builder is fine of S dot reverse dot toString. And that should work, right? So now we need to take this, reverse it, and we'll open our app properties. And we already have a function in here. So what can we do? We can chain our functions, just like piping in Linux. It's so nice. Okay, so I'm going to restart this, and as long as we got them all, right? Look at that. Okay, so let's go back to our source. That's our source, and we'll restart this. And what we should see is outputs where everything is uppercase and reversed. Look at that. It all works. Yay. Okay, so I had a couple other things I was hoping to show you, but it's not going to happen, at least not right now. Maybe I can squeeze them into tomorrow's keynote here a little bit. So I'm going to go ahead and shut this off, and we'll go back and wrap it up and go grab some coffee. All right, so turning it up to 11, where do we go from here? Well, I've given you a little bit of a hint, but we've kind of talked about these things mostly together, but they're not entirely together, right? We have all of Spring Cloud Stream that's working pretty well, and we've got some function chaining going on, which is nice. We have reactive programming. We're dealing with publishers, but what we're missing is that one last little element of, for instance, with Rabbit, we have reactive drivers. We don't yet have a completed reactive binder, and once we get that, we'll be able to push values all throughout the pipeline, no matter how long that pipeline may be, with things like the Rabbit reactive binder and drivers, and of course Kafka K-streams as well, which we do have capabilities for, but everything isn't fully integrated the way I want it yet. That's on my list. So it gives you a little bit of a hint of where it's going, and it looks good. The future is bright. So some takeaway resources. First, everything that you saw here in terms of code and then some are in the top repo, Building Reactive Pipelines, my GitHub repo. The Spring Cloud Stream homepage is the jumping off point for that. It can point you to the GitHub repo, again, fully open source, as well as documentation, API docs, and all that. The Project Reactor page, which also, again, points you to the repo, to the documentation, what have you. If you have any questions, comments, or feedback, please do email me if you must. I don't check email as often as I do Twitter, but I do check it from time to time. And preferably, if you have any feedback at all, shoot me a link, a message on Twitter, right? Direct message, or just post it on Twitter at mkheck. And with that, thanks for coming, and enjoy Vox Days Bucharest. And excellent mob programming. Yes, so shout out to you.